Welcome back, everybody. Today we're going to be diving into something really interesting, a new system called SELA, in the world of machine learning, that is. And you know AutoML, you know it's all about automating the process of building machine learning models. But as good as some of the methods that we have right now are, they kind of have their limitations. Like they haven't quite figured out how to get the best of both worlds, you know?
Yeah, you're right. Traditional AutoML systems, they're great at optimizing specific parts of the process, but they just don't have that much flexibility. It's kind of like you're following a recipe, and
Mm.
you can only change like a couple of ingredients. Then on the other hand, you've got the newer LLM-based agents,
Mhm.
and they use natural language processing, so they're definitely more adaptable. But sometimes they get stuck in a rut, and they don't always give you the absolute best result.
So that's where SELA comes in.
Right. This could be the solution we've all been waiting for.
It sounds like it.
What SELA does is it combines the best parts of both approaches. So it uses that flexibility
Hmm.
of LLMs, and then it adds in a very clever search process to find the most effective solutions.
Okay. And how does it do that?
Well, SELA has three main parts that work together. So the first part is what's called the LLM-based insight proposer.
Okay.
And this is really where SELA gets creative. It uses an LLM to basically brainstorm a
Yeah.
whole bunch of different potential strategies.
So it's like a brainstorming session with like a super smart AI.
Exactly.
Wow.
But it doesn't stop there. So then next comes the search module, and this uses something called Monte Carlo Tree Search. Essentially, it's kind of like SELA is playing a strategic game.
Okay.
So it's testing out these different strategies that the insight proposer has suggested, and it's figuring out which of those strategies is most likely to lead to a good result.
So it's not just like throwing a bunch of ideas at the wall and seeing what sticks, it's evaluating them strategically.
Right, exactly.
Mhm.
And then the third part is the LLM agent. So you can think of this as the executor. It's going to take the best strategies that the search module has identified, and then it's going to go ahead and actually build the experiment.
Mm.
So it's writing the code and it's running it.
So it goes from brainstorming to strategizing to actually building and testing.
Exactly.
That's really impressive.
Yeah. What's really remarkable about SELA is how adaptable it is. You can give it all sorts of data sets and problems. You can do classification tasks, regression tasks. It's like you have this machine learning expert who can tackle anything you throw at it.
And does it deliver?
Well, the results are really promising. So the researchers tested SLA on 20 different data sets,
Wow.
and it had a win rate of between 65 and 80% against existing AutoML methods.
That's huge.
Yeah, it's a big improvement.
Yeah.
And even when SLA didn't get the absolute best result, it was usually very close to the best.
Mm.
So this means that it's consistently reliable. And that's really a big deal in the world of machine learning.
Yeah, for sure.
And there's another interesting thing too. The specific LLM that's used for the insight proposer and the agent doesn't really seem to matter.
So it's not limited to just one type of LLM.
Right.
Okay, so that makes it even more versatile.
It does, yeah. But to really understand what makes SELA work, the researchers did what's called an ablation study.
Okay.
So basically, they took SEL apart and tested its individual components to see how important each one was.
Okay, so like taking apart a car engine to see how each part contributes to the whole thing.
Yeah, exactly, like that. And what they found was that SEL's strategic search process, the part that uses Monte Carlo Tree Search,
Hmm.
is absolutely essential. If you just pick strategies randomly, it just doesn't work as well.
So it's the combination of that like smart brainstorming
Yeah.
and then that strategic decision making
Yeah.
that really gives SEL its edge.
Right, exactly.
And you mentioned an example before about like predicting customer churn. Can
Yeah.
you like unpack that a little bit? So how would SELA actually tackle a problem like that?
Yeah, so let's say you have a data set with information about your customers. Things like demographics and their usage patterns, maybe their past interactions with your service.
And the goal is to figure out who's going to cancel their subscription.
Yeah, exactly. So you would give all that data to SE and you would tell it, I want to predict churn. And then the LLM-based insight proposer would start brainstorming different strategies.
Okay.
So it might come up with insights like, maybe we should create a new feature that combines the customer's age with how long they've been a subscriber.
So it's looking for like patterns and connections in the data that might indicate that someone's about to churn.
Yeah, exactly. Or it might say, hey, let's try using this specific type of machine learning model that's known to be effective for churn prediction.
Okay.
And then the search module would kick in. And it would
Got it.
start testing out these different strategies
Got it.
to see which one works best. And it's not just picking them randomly, it's strategically exploring the most promising paths just like a really good chess player would do.
So that's where SE really shines.
Yep.
It's like running through all the possible scenarios.
It can run through hundreds or even thousands of simulations,
Wow.
learning from each one
Wow.
and constantly improving its approach.
So it's not just about automation, it's also about optimization.
Right.
Finding like the absolute best way to build a model for that specific problem.
Exactly.
Now you mentioned earlier these rollouts. Can you explain how those fit into this whole thing?
Yeah, so remember, Hella learns by trying things out. So
Right.
each rollout is basically like one complete run
Yeah.
of that whole process, from generating insights to building and evaluating the model.
Okay.
So the more rollouts SELA gets, the more experience it gains, and the better it becomes at picking the right strategies.
So it's like practicing, right? The more it practices, the better it gets.
Exactly. It's like practice.
Okay, cool.
And what the researchers found is that SELA's performance generally improved as it was given more rollouts. But of course, there's a trade-off. More rollouts means you need more computational time and resources.
So there's like a balance to be struck there. You want SELA to practice enough to be good at what it does, but you don't want it to take forever.
Exactly.
So what else did the researchers discover about how SELA works?
Well, they also found that SELA is really robust. Remember how we talked about how the choice of base LLM doesn't seem to matter that much?
Yeah.
Well, that's a really big deal.
Yeah.
Because it means that SELA is very adaptable.
Yeah.
And it can be used in all sorts of different situations.
That's very cool.
Yeah, it's not limited to one specific type of LLM, so that gives you more flexibility.
Very impressive. It sounds like SELA is a major step forward for AutoML. But I'm curious, what does this mean for the bigger picture? Like, where could all of this lead?
That's a great question. And I think the success of SELA goes beyond just automating machine learning. I think it shows us the power of combining human-like reasoning with computational efficiency.
So you're saying that SELA's approach could be applied to other areas, not just machine learning.
Absolutely.
Yeah.
Imagine using the same approach to design scientific experiments,
Do.
or to optimize complex processes in a factory, or even to create personalized education plans for students.
Wow. That's a lot to think about.
It is. The potential applications are really vast.
Yeah. So to sum up, SELA is this powerful new system that's really kind of shaking up the world of AutoML. It combines the flexibility of LLMs with this really strategic search process to find the best solutions. It's adaptable, it's robust, and it's incredibly effective. But I think the most exciting part is that it really hints at a future where this kind of AI-powered problem solving could be applied to all sorts of challenges, not just machine learning.
And that's what makes SELA so groundbreaking. It's not just about automating tasks. It's about opening up this whole new world of possibilities and pushing the boundaries of what's possible with AI
Yeah.
and really exploring the potential for humans and machines to work together.
It's almost like SELA is giving us a glimpse into the future of problem solving, where AI can help us tackle even the most complex challenges. It's pretty mind-blowing to think about where all of this could lead. We've been talking about SELA and its potential to just revolutionize machine learning, but you're saying that this could be just the tip of the iceberg.
Exactly. I think the principles behind SELA, this combination of flexible AI and strategic search, could be applied to so many other fields.
So instead of just automating tasks, we're talking about AI that can actually help us strategize and solve complex problems in a way that we as humans might not even think of.
Exactly. Think about scientific research. Imagine if SELA could help scientists design experiments or analyze data in ways that could lead to groundbreaking discoveries.
Yeah. Or in medicine. Could it help doctors diagnose diseases more accurately? Or develop personalized treatment plans?
Absolutely. And think about areas like urban planning or climate modeling.
Yeah.
These are incredibly complex problems with huge data sets. SELA could help us find solutions that are more effective and more sustainable.
It's exciting to think about all the possibilities, but it also makes you wonder, what does this mean for us? Are we talking about a future where AI is making all the decisions?
Yeah, that's an important question, but I see it more as a collaboration. You know, SELA and systems like it can help us explore a wider range of possibilities, help us find solutions more efficiently, and ultimately help us make better decisions. So it's about augmenting human intelligence, not replacing it.
So it's like having a super smart partner to bounce ideas off of and help us navigate all these complex challenges.
Exactly. And the more AI systems like SELA evolve, the more sophisticated and intuitive they'll become. It's not hard to imagine a future where interacting with these systems feels as natural as collaborating with a human colleague.
And as these AI systems get better at problem solving, we can really focus on the things that humans are uniquely good at. Things like creativity, empathy, critical thinking.
Right. It's about finding the right balance.
Mhm.
where AI takes care of the tasks that are best suited for machines. And it frees us up to focus on what makes us human.
Well, I think it's safe to say that SELA has given us a lot to think about. It's not just some cool new technology, it's a glimpse into a future where AI plays a much bigger role in our lives, helping us tackle some of the world's most challenging problems.
Yeah, and that's what makes this field so fascinating.
Yeah.
It's constantly evolving,
Right.
and we're really just beginning to scratch the surface of what's possible.
It's definitely an exciting time to be following the world of AI. And for our listeners, if SELA has sparked your curiosity, I encourage you to dive deeper into the research. There's a whole world of information out there. And who knows, maybe you'll be inspired to develop the next groundbreaking AI system.
Yeah, the possibilities are truly endless.
That's it for our deep dive today. Thanks for joining us. And until next time, keep exploring, keep learning, and keep asking questions.
Yeah, it's not as complex as it sounds. Imagine like you're playing a game of chess. Each move that you make opens up a whole bunch of different possibilities
Yeah.
for your opponent and then for you again, and so on and so on. And so Monte Carlo Tree Search is kind of like that.
So SEO is like looking ahead and trying to anticipate the best moves.
Exactly. So it's simulating all these different scenarios, it's testing out different strategies, and then it sees how those strategies actually play out.
Mm.
And the more simulations that it runs, the better it understands which paths are most likely to lead to success.
So SEO is actually learning as it goes. It's refining its approach
Okay.
based on those simulations.
That's right. It's like having this AI that gets smarter with every experiment that it runs.
That's pretty amazing. So to go back to your example about predicting customer churn, how would SEO tackle that?
Okay, so let's say that you have a data set with information about your customers, things like their demographics, their usage patterns, their past interactions with your service.
And the goal is to figure out who's most likely to cancel.
Exactly. So you would feed all that data into SD, and you would tell it, okay, I want to predict churn. And then the LLM-based insight proposer would start brainstorming all these different strategies. So it might come up with insights like maybe we should create a new feature that combines the